Hi everyone, Mr. Oliver here from the Prendergast Library, here with another STEAM concepts from our makerspace. So today, I'm going to show you a couple different things, but we're going to start with these two pattern play, let's call them games. So this one is called Pattern Play Revolution, and this one is Pattern Play Color by Design. So this one is the Pattern Play Color by Design. So it's got a square border, and it has some different shapes on here. So we have small triangles, and then we have quadrilaterals. And so the quadrilaterals come in, it looks like two different sizes. We have, I'm gonna tilt this so it doesn't fall. We have the small ones, and then we have these larger ones. And so with this, kids are able to, or not just kids, everybody, they'll be given these cards. And there's a bunch of different cards that come in these boxes. And what they have is different shapes they can make. It always makes me think of stained glass. But what they do is they rearrange the blocks on here to create these different patterns. I'm gonna hold up one of these patterns real quick. So, as we see with this pattern here, it repeats, so it goes purple, blue, blue, purple, purple, blue, blue, purple, purple, blue. And then up here it does the same thing. So yellow, green, green, yellow, yellow, green, green, yellow. And it's bookended on top and bottom by two light blue strips. And so this is a pattern that whoever's using this pattern play color by design setup has to recreate. Now similarly, the pattern play revolution, say that 5 times fast, has these cards as well, but they're actually double-sided. And so like this one, basic stripes, or basic wedges, sorry, of color. And then if I turn it over, it takes those wedges and they put stripes in them. So what I've done with this, and ours is a little beat up, it's gotten a lot of use, is I've created two patterns on this one that I've just created. So we have, going from this side, so we have line, line, curve, line, line, curve. So that's your first pattern. So it'd be 1, 1, 2, 1, 1, 2. And then if you also see, the colors shift by 1 each time. So let's track the light blue that's down here at the bottom and see the pattern. So it's light blue, light blue, light blue, light blue, light blue, and then it's really small, but there's another light blue right there. So it moves around and goes in like a spiral. And you can track any of these colors, and it does the same thing. So, I'm sure many of you are sitting there watching this going, but how does patterns fit into STEAM? So remember, STEAM is science, technology, engineering, art, and math. So obviously we have patterns in art. I mentioned stained glass before, but patterns are a very important concept of the foundations of our learning process. So think back when you were a kid, or think back when you were raising your kids, when you were teaching them to speak and to read, you would say a sound and you would show them how it was spelled or what letter that sound was made by. Take, for example, the word good. So you would show them that on a piece of paper or in a book, and you would say good. And then you would say goodbye, good morning, good day. And so by reinforcing that those 4 letters made that sound, when they got older, or when you got older, and you saw the poet Goodfellow, you knew that that's how his name sounded because you recognized the pattern of those 4 letters. Now, I know not all of you have started to learn multiplication in math yet, but multiplication is all about patterns. In fact, all of math is all about patterns. As you get into more advanced math, you start learning about laws and rules, and really all they are patterns on how they work. So, I'm going to snap my fingers. This table will be cleared of some of this stuff, and I'm going to show you some multiplication real quick on there. Some really cool patterns, and we'll be right back. So, I'm going to show you guys some quick multiplication. So this is the zeros multiplication tables. And as we see here, that no matter what number you multiply 0 by, it still equals 0. Because no matter how much you increase 0, it's still 0. And then this is supposed to be the two times tables, but I flipped it around here. That's okay. And as you see, that every time you multiply by 2, you double the number you get. And as we go over here to 5s, the 5 multiplication tables are interesting. So the number you get is always going to end in either a 5 or a 0. But if you multiply 5 by an even number, so 2 and 4 in this case, it ends in a 0. But if you multiply by an odd number, so 1, 3, and 5, it ends in a 5. So you remember when I showed you guys the circle, I had 2 different patterns in there? That's this pattern as well, or a similar pattern. Now, the 10 times table is, for me, when I was learning multiplication, the easiest ones for me to remember. Because you just took whatever this number is, and you put a 0 after it. So 2 times 10 is 20, 3 times 10 is 30, and 5 times 10 is 50. So those are some kind of basic patterns. And then I'm going to show you one more multiplication times table. And this is actually my favorite. So back when I was in college, I studied a lot of maths. And I loved the 9 times tables because there's a couple different patterns in here. So if you want to learn to cheat on your multiplication tables, don't tell your teacher, but we're going to learn this real quick. So when you're multiplying, 9 times 1 is 9, 9 times 2 is 18. And so what happens is in the ones column, it starts at 9, and as you go down, it counts all the way down to 0. But in the tens column, it goes from 0 all the way up till 9. And as you can see right here, so 9 times 5 and 9 times 6, they flip. So 9 times 5 is 45, and 9 times 6 is 54. It's really cool. And when I was talking to Miss Joanna the other day, I pointed something out to her, that if you actually add these 2 numbers on all of them, you get 9. And it doesn't matter how big of a number you take, because one of the things about patterns is the pattern has to hold true no matter how large it gets. So, you guys don't know this, but Miss Joanna helped me film this. So I'm going to ask her for a 4-digit number, and that number is
7,522.
So, I'm going to write that down here. Mind my head real quick, guys. So 7,522 times 9 equals, I have to do it on my calculator because my brain doesn't work that well.
I thought it was divided by.
Nope. So, the number is 67,698. So, if I add those numbers together, that equals 36. And if I add 3 and 6 together, I get 9. So,
Does it work with division too?
you know, I'm not sure. Let's find out. So, we're going to take this same number here. No, not quite, because 7,522 divided by 9 equals, sorry, 835.77. So not quite. Let's see. It gets really close though. 8 plus 3 plus 5 is 16. And let's see, plus 7 plus 7. Yeah, so that would equal 30.
What if you rounded it up? 836.
That's a good question. So 8 plus 3 plus 6 equals 17.
I'm just messing you all up, aren't I?
You are. That's actually a really important question to ask about patterns, is because sometimes you have to find out where a pattern doesn't hold true. So just because something works for multiplication doesn't mean it's going to work for addition or for division. Just like sometimes when you add numbers together, it doesn't always work the same way with subtraction. So, really important thing to think about. And what I would like you guys to do is start looking at the patterns that you see in the world around you. It could be the way the leaves change color on certain trees. It could be the number of petals on plants. Or if you have a dog and it starts barking, see if it barks at the same time every day. Because the pattern might be the mailman. Have a good day, guys.